This was the bell work. I'm doing a quick video because I forgot to record the two classes on Monday, October 3rd. So this was the bell work. I'm going to quickly solve the bell work, and then I will move into the super fast lesson we did on absolute value, solving for a variable in an equation with absolute value. So the first thing I pointed out, this is going to be on the next quiz. So there's going to be some free retakes based on all three of these equations. The top two equations, number 1 and number 2, are really just two-step equations. Number 3 is a proportion equation. Now, I'm going to solve number 1 two different ways because number 1 could also be done using a proportion, but it can be done using kind of the general two-step equation steps. So I'm going to do number 3 first. The way we know something is a proportion is that we have two fractions on both sides of the equal sign. So you can see here, and I'm going to kind of zoom in on the screen real quick. You can see here for this number 3, problem number 3, everything on the left side of the equation is either above or below the fraction line. So that 2x subtract 1 is above the fraction line. The 4 is below. On the right side of the equation, we also have a fraction. So I have a fraction on the left and a fraction on the right. And then again, everything on the right side of the equation is either above or below the fraction line. So this is set up for a proportion. That's how you know it's set up for a proportion, is you have two fractions, a fraction on the left, a fraction on the right, and everything in the problem is either above or below the fraction line. And I'll explain that in a little more detail when we do number 2. So from here, I can just go ahead and get rid of what I just drew in. I can go ahead and do the butterfly thing. So the butterfly thing, we said we draw these butterfly wings, and what we're doing is we're cross multiplying. So when we solve a proportion, we're cross multiplying, but we draw those little sort of circles, and we call those butterfly wings, is what I mean by the butterfly thing. So within each individual butterfly wing, actually let's color coordinate. So one will make red and black, one is just red. So within a butterfly wing, we're going to multiply those things together. So we're going to multiply that 4 times that 3, and that would give us 12. In the other butterfly wing, which I'll do in red, and this is the trickier part, I am multiplying this 5 right here, and I'm going to multiply it times the 2x, and I'm going to also multiply it times the subtract 1. A lot of people didn't do this part correctly on the quiz when we did proportions before. Somehow, and I don't exactly know how, somehow people were trying to come up with just one term. They were multiplying this number down here times this whole thing here, and they were just coming up with one number somehow. Not exactly sure what they were doing. So just remember, this 5 has to be multiplied times both of the two terms that are in this upper part of the butterfly. You could also think of it as this way. You could say this needs to be multiplied times 5, and this needs to be multiplied times 5. That little dot is for multiplication, not a decimal. I'm going to show you even a third way that I taught, but you could do it like that, say times 5 and times 5. The way I showed you before is you take 5 and you multiply it, and then in parentheses, we write the 2x subtract 1. And then that's when we did like the drawing the little lines thing for the distributive property. So 5 times 2x is 10x, and then 5 times -1 is subtract 5. So once you come up with the answer to each separate butterfly wing, you just set that equal to each other. So we would say, okay, well, one of my answers was 12. That was one butterfly wing. And the other butterfly wing was 10x subtract 5. Now it's just a two-step equation. We always start farther away from the variable, and our goal is to get the x by itself. So I want to get rid of the 10. I want to get rid of the -5. Well, I always start farthest away from the variable, which is the -5 part, the subtract 5. So once I do that on the right side, I have to do the same exact thing on the left side. Well, that gives me positive 17 equals 10x. I just bring the 10x down. And then my last step, if this is 10 times x on the right, 10 times x, well, then I need to do the opposite, which is divide by 10. Well, I need to do the opposite over here and divide by 10. So my final answer, and some people tried to simplify fractions that couldn't be simplified. My final answer is 17/10. 17 is not an even number, so I can't divide that by 2, which some people tried to divide an odd number by 2. That's the final answer. So that's a proportion problem. It's already set up as a proportion. There's nothing I had to do. I just immediately do the butterfly wings. I'm going to zoom back out a little bit. Try to get the whole there. That's pretty much the whole problem. So now let's go up and let's do the other problems. Zoom out and slide on this down. Room. All right, so now problem number 1 is not already set up to be a proportion, but I could make a very simple change and it would be set up to do a proportion. If I just took that problem and said, well, you know what? This is really the same thing as x plus 5 over 3 equals, and we said we can change any integer into a fraction by putting it over 1. Now that it's set up like that, I could just do the whole butterfly thing again, which I'm going to do it a different way. So I'm going to do the butterfly thing super fast. I would make my butterfly wings 1 times x plus 5. So this wing right here is 1 times x plus 5. Well, that's just x plus 5. In my other wing, it's 2 times 6. So that, I'm sorry, 2 times 3, which gives me 6. That is the new equation. I would just solve for x by subtracting 5 and subtracting 5, and that would give me x all by itself, and that equals 1. So x would be 1. Now the other way to solve this, which I will also do, if I don't like this whole butterfly method and the proportions and cross multiplying, I can actually just solve this like a 2-step equation. If I look at problem number 1, I'm going to zoom in now. I could say, well, you know what? I really just want to get this x all by itself, which means I need to get rid of the 5 and I need to get rid of the 3. All I got to do to get rid of those things is opposite math. So now I need to think about it. Which one of those 2 numbers would I consider to be farthest away from the x? And that's the tricky part. Farthest away from the x in this case is actually the bottom number, 3. That is considered to be farther away from x. The other way you could maybe think about it is if let's say I wanted to get rid of the 5, I'd try to subtract 5. Well, I can't subtract 5 from all of this, because remember, that's a fraction. If I try to take that and subtract 5, I would need the same common denominator. It just wouldn't work out very well. It's not something I can easily do. So subtracting 5 can't be the correct first step. However you need to remember it, though, you need to understand the correct first step in here is to get rid of the 3 first. And I do that by doing the opposite math. If this line means divide, so I'm dividing by 3, then I need to multiply times 3. And that'll cancel those 2 out. They'll go to 1 technically, but then over here, I would also have to multiply by 3. So I get x plus 5 is still left. And that equals 6, which is what I just had when I did it the proportion way. And then again, you can subtract 5, and x is still equal to 1. Now the problem on the right, number 2, this problem is not set up for a proportion. There is no way to do a proportion the way it is right now. We can do one step and get it set up as a proportion, but the key is this 5 right here is not over or underneath the division line, the fraction line. If it's not, then we can't do proportions. Like on the left side, this x plus 5 was over the division line. That was over the division line. The 3 is under the division line. when I set up the fraction, 2 was over the division line, 1 was under the division line. So they were both fractions on both sides. This 5 is not a fraction. And even if I changed it into a fraction, it wouldn't work because I wouldn't have the same denominator as this 3 right here. If you didn't follow all of that, it's not super, super important. I'm just going to kind of show you that this one is just done the same way we would do a normal two-step equation. If this is the variable here, and I want that alone, this 5 is farther away than this 3, and I want to get rid of both of those. So I just start with the number farthest away, and I would say subtract 5, subtract 5. Well, that gets rid of the 5s. I get negative 3 over here equals y over 3. Again, it's not a proportion, but I could change it to a proportion if I wanted to. And I could make the negative 3 over 1. I'm not going to do that because there's really only one more step. If I want y all by itself, I just need to do the opposite math to get rid of that 3 right here. Get rid of this 3. Well, if I'm in the problem, I'm saying y divided by 3 because that's what this line means. That means division. So if this is y divided by 3, I just need to do the opposite and multiply times 3. Well, I multiply times 3 there. I got to multiply times 3 there. That would give me y equals negative 9. Now, a lot of you are still struggling, even though we've been working on those fractions. So I'm going to give you a third method that we really haven't talked about, and that's just kind of figuring it out. So let's go back to the original problem. So I'm going to kind of go backwards for a while, and I'm going to show you what you can kind of just do and just figure out problems sometimes. Doesn't always work. But in these it does. I'll show you how it does. So if I know that I want this side to be equal to 2, because that's what's on the right side. That's what an equation is. Left side equals the right side. I want it to be equal to 2. Well, if that's the case, then I just need to figure out, well, what number, so this top number here, would have to be 6, because 6 divided by 3 is going to give me 2. So everything in this box right here, when I say x plus 5, that has to be 6. Well, what number plus 5 is 6? Well, 1. 1 plus 5 would give me 6 on top. So I could just show that 1 plus 5 divided by 3 equals 2. And I'd be even fine with that. And then same thing over here. What number plus 5, so this number here, plus 5 has to be 2. Well, it's a little trickier, but you should eventually figure out that this rectangle here has to be negative 3. So y divided by 3 has to be negative 3. Well, the only thing that gives me negative 3 when I divide by 3 is negative 9. So that would be an answer. You could even write, show me that you understand that that's the correct answer, because negative 9 divided by 3 plus 5 equals 2. I'm going to try to do this last absolute value thing super fast. I might not even do the full version. So we're doing absolute value problems. What absolute value means is the distance from 0. So if my number in the brackets, so these brackets mean absolute value. So if I have a 3 in those brackets, that means how far is the number 3? So I'll put a point on it right here. The number 3, how far is that from 0? Well, if you measure the length of that line segment, it's 1, 2, 3 units away. The trick is the number negative 3 is also 3 units away. So the absolute value of negative 3 is actually positive 3. So, because again, if this is negative 3 right here, well, negative 3 is 3 units away from 0. So the absolute value of negative 3 is positive 3. So when you go through and you do equations with absolute value, the only trick is you solve the equation just like it's written, only you take away the absolute value signs. So in this particular equation here, let me see if I can make a little room. In this particular equation here, I would just solve the equation x plus 2 equals 5. And if I solve that out, it gives me x equals 3, which is what I have right here. And then if I plug it back in, I get 5 on the left and 5 on the right. But then I have to solve a second equation, and I change the value of the answer. So this answer right here, I need to change that to 5. Because if I solve that out, and if I come up with -7, if you'll notice, when I plug in -7 into the original equation, so that was x, -7 plus 2 equals -5. But remember, we have the absolute value signs around that answer in the original equation. So the absolute value of -5 is 5, which is what is on the right side of the equation right here. So again, I went through that super fast. I didn't want to record a whole lesson on it just for like, or a whole period just for like 5 minutes of lesson, although we did a little more detail in class. Just remember, solve the original equation just like it is without the absolute value symbol. So I just took the absolute value symbols away. Then solve the equation again, but change the answer in the original problem to a negative number. So instead of +5, I changed it to -5. Then I just solved out for x. So you'll get 2 answers. So your final answer to the problem is x equals 3 or x equals -7. You can watch other videos on solving equations with absolute value if you want to, but that should get you through my quiz.